Hi, everybody. It's Dr. Campbell, and we're continuing with our remote science fair work today. So now we're going to do Garrett's project. And if you need to stop this video to continue to get Garrett's project written into your notebook, please do so. I know some of the girls are working on something else right now, but all the boys should be working on this particular project. So in Google Classroom, I've put this particular sheet. I'm sorry, not Google Sheet, a Google Doc. And what we're looking at is how temperature affects the dissolving time of aspirin. Well, how are we going to know that? Well, aspirin is really made out of salicylic acid. So it's an acid. And usually the pH of aspirin is about 3.5, all right? Whereas the pH of distilled water is about 7. So we will know the aspirin has dissolved if the pH of the water it's in actually changes from a, say, 7 or 6 something down to closer to 3.5. So we're going to watch the final pH, see if we can get to the 3.5, and we're also going to put the time that it took to do that. All right. Now, let me talk about type of aspirin you use. You have to use actual true aspirin. You can't use Tylenol. That's not aspirin. Or Aleve or ibuprofen. Those are not aspirins. You are actually looking for an aspirin just like this. This is Bayer aspirin. And it's truly salicylic acid. That's what's in this. I did talk to Garrett before we started this lab, though. However, this Bayer aspirin, they said they're coated, but when I tested them in the lab, it took like 2 seconds, literally 2 seconds, and it was totally dissolved into solution. So I decided to choose a different aspirin, and this is just a different brand name, and this is Anacin, but it's still salicylic acid. Okay, so it's the same stuff. I just think it's coated a little differently. I tested it too. It still was quick, like 4 seconds, but not as quick as the Bayer, and I think we'll get better data using this. So we had test a little bit something here. Okay, so what I'm going to do is I'm going to pause the video so that I can switch cameras really quickly while and what you need to do is you need to get on Google Docs and you need to open this up. It'll be in your Google account. Need to open this up and get out a ruler and put Garrett's chart into your lab notebook. And this will be for all the guys in my class and maybe a few of the girls who are already done with all their projects. So we're not typing on it. It's not going to be shareable for typing. It's only going to be write it into it. So let me stop my video a minute. By the way, whenever we're working on something, this is a video, it's on my YouTube channel. So if you have to stop the video so you can do something, then stop the video. You can always just restart it. Since it's a YouTube video, you can restart it pretty easily. So let me pause just a second. Hi, everybody. So we're back, and I now have this whole thing set up. I set it at 5 minutes because I don't really know how long it's going to take. But you can see that I have one set with temperature 1 and temperature 2, and then pH 1 and pH 2. So what I did was I set a temperature probe and a pH probe together inside of a beaker or inside of a jelly jar, whatever, a pint jar. And so I'm also going to record a little bit with my phone, which you won't be able to see that, but the phone's up here. So we're able to collect data a little bit. So now what I'm going to do is I'm going to open the Anacin. And what I'm going to do is I'm going to hit collect so that we have initial data to go with. And if you'll notice down in the bottom corner, one pH says 7.52 and one says 6.43. Now, I'm going to guess that the probes are not as, what's the word I want, as accurate right now because they've been sitting in the lab and we couldn't check them with a buffer solution to make sure they're okay and working all right. So we're just going to have to go with the initial data that it's giving us, even though pH of water is a 7 and I tested with pH paper, it's a 7. So, and it's just because these have been sitting in a cabinet in the chemistry room. And because we were on lockdown, I couldn't get in there to be able to get the buffer solution to make sure it's a real accurate data collection as far as current is at 7. So that's why the pH looks a little off. Temperatures are consistent though. 18.1 and 18.2. It's not really room temperature. Room temperature is 23, which is about 70. But usually when you have distilled water, and I use distilled water in a jug, it's probably going to be closer to 20 or a little lower than that because it is whatever it is inside the plastic. So first thing I'm going to do is I'm going to hit collect. And you can see now it's already started collecting data. Now, because it's a 5-minute mark, it's probably not going to show on the screen right away. It's so many minutes. Okay, I think I put it at 100 minutes, so I should probably stop that because I don't want 100 minutes. Let me reset it. I don't know. I thought I put it at 5 minutes, but it says 100 minutes down here, so that doesn't really make much sense. So let me start a new one. I'm not going to save my changes. And now it's going to open it up again with the pH and the temperature. No changes there. And down here it says 100 seconds or 200 seconds, right? I think it's 120. So I'm going to go up here. I'm going to ask for data collection. And I'm going to say 5 minutes. Actually, I'm just going to do 3. No, I'll do 5 because I don't know how long it's going to take when we do cold. And I'm going to do minutes. And we're going to click done. We're going to see there, 5 minutes. That's a lot better. A lot better. Okay. Now I'm going to hit temperature. I'm going to hit collect. All right. And it should start collecting right away. Yep. Now what I'm going to do is I'm going to reach over the computer and I'm going to put 2 aspirin tablets in the center of the computer, in the center of the jar. And I'm also going to start my camera on my phone so we can see if we can see when they start to dissolve really quickly. And I put those tablets in fairly close to the pH sensor. So we'll see what happens. I don't know why I'm not. Oh, I guess the line is, it's close. The red and the green line are so close together. It's really not showing me a change. And those tablets have not dissolved yet. They look like they're getting ready to dissolve. They're kind of puffing up a little bit. So we'll see what happens here. So I have a camera on it so that we can run the data but that way. And it looks like the aspirin tablet is starting to dissolve a little bit. So I'm going to stop my video so that I can check on the data. Okay, so I'm just going to stop the video really quickly. This is going to run in the background. Okay, so we are looking back at this data now. We've got something kind of hinky going on, and I'm just going to show you what's up. The aspirin tablet is starting to dissolve, but let's look at the data. Look what happened. The pH on 1 went up. It went from 7.4 to 7.7, which does not make any sense. And I can't really see the other data. Let me go over here. The pH on the other one went down. Okay, so this one's going up and this is going down. So in this case, we're going to stop the lab because we aren't actually able to finish the lab because something is wrong with the pH sensors. So what we'll do, and that's okay, we'll probably have to wait for Garret for when we come back in January so he can actually conduct it in class, because like now you can see this is still going down, the 606 compared to 6.4, and this is still kind of up there. So this is still moving. So this is live data collection. This is done now. So what we'll do, sorry, Garret, we will come back in January to be able to do this. Now, for everybody so that you know what's going on in class. My goal is we're still going to try and get these projects done. Whoever we cannot get done this week or early next week, depending, we will go ahead and do it in January because they're pretty short projects. So Hayden's project, Parker's project, and possibly who's left up? Can't remember. The girls should be all done with theirs. So I think I have 3 projects that we have left to do. And then Marcos, we need his data as well. So Marcos is running his project at home. And then Braden Parks has still got to run his siphon data. Okay. So what we'll probably do is starting tomorrow, Friday, and then following into the next week is we're going to do some writing stuff. So today you're supposed to get your packets back, and Lucy, I will make sure I get a copy of your packet to you, so you don't have to worry about it. So I think we'll take a picture of it. We'll take a picture of everything. So it's probably sitting in the lab actually, and I can't get in there right now. I'm not able to get in there. So we will go ahead and get your pictures of your packet to you, and every page of the multiple things, and then we'll send it to you where you are right now. So what we'll do is I'm going to have you log off, and I need you to put all your supplies away. And then starting tomorrow, we will go ahead and look at some other ways to do your writing and stuff like that. So hopefully it wasn't as helpful as we wanted to, but at least we kind of know what's going on right now. So I'm going to click out of this, and we will stop the video, and we'll just go from there.